This section is on inequalities and their graphs. So just a really quick preview about what an inequality is. For the most part in math we work with equations. An equation is something like 8 equals 2 times 4. We call it an equation because there's an equal sign here, where you have just one side of the math problem equals the other side of the math problem. An inequality is a little bit different, where one side might not necessarily equal the other side. For example, if we had a 6 here, and 2 times 4, well, 6 is less than 2 times 4. So we use the inequality symbol for less than. So I'm just going to make a little note of that, and you can on your paper. About what a less than sign is. Now what helps me remember as far as which one's less than and which one's greater than, I always think about an alligator. An alligator is hungry, and an alligator opens its mouth to the bigger animal or the bigger bite or the bigger piece of food. So here, this inequality symbol is open to 2 times 4 because that's 8. So this alligator wants to eat the 8 because it's higher. So this is red, 6 is less than 8, and the inequality sign is always open towards the bigger part of the problem. Let's think about a sign that would be greater than. Let's use the number 10. 10 is greater than 2 times 4. And again, that means our alligator mouth is open towards our 10, because the alligator likes to eat the higher amount. So maybe you want to make a note of that also. Greater than. Can't quite fit on there. Okay, so as far as inequality goes, usually it's less than or greater than, and sometimes you'll have a problem where it's less than or equal to. So let's go back to our 8. Again, if we had 8 and 2 times 4, we can use an inequality sign here. If we say 8 is less than or equal to 2 times 4, this symbol here, the line underneath the less than sign, means that when you read it, you say or equal to. So this is less than or equal to 2 times 4. And you could also say that 8 is greater than or equal to 2 times 4 because 8 is equal to 2 times 4. Okay, so that's just a little intro into inequalities. Now we're going to talk about how to represent an inequality on a number line. Okay, inequalities and their graphs. So this inequality has a variable with it, x. This is red, x is less than or equal to 1. Try to make that a little bit bigger for you. Okay, so when I think about the numbers that are less than or equal to 1, there's a lot of numbers out there that I can plug in for x. 0 is less than or equal to 1. Negative 4 is less than or equal to 1. Negative 20 is less than or equal to 1. So when I graph this, I want to show all of the possibilities for x here. So on the number line, I go over to the 1, and I put in a dot. And I show that x is all numbers that are less than or equal to 1. So I'm going to show an arrow pointing to all numbers that are less than 1. Okay? And that is how you graph this inequality. X is less than or equal to 1. Let's do another one. I'm actually going to go over here to number 2. Alright, this is red. The variable m is greater than negative 2. So I'm going to look at my number line. Here's negative 2. And this means that m is all numbers that are greater than this negative 2. So it's going to be all numbers higher, going to the right on the number line. So this is a little different than number 1 because there is no equal to sign here. When the inequality symbol is just less than or greater than, we're going to, instead of putting a closed dot on the number line, we're going to use an open circle. Okay? So instead of closing this dot up, I'm using an open circle because this says that m is greater than -2, m is not -2. And now I'm going to draw my arrow. M is all numbers greater than -2. Could be. All right, number 3. X is the variable less than or equal to 4. So I want to think about x. What could x be? X could be any number less than or equal to 4. So there is the equal to sign here. So I have to think, do I put an open circle here or a closed dot? Since there's the equal to line here, I'm going to use a closed dot because x could be 4. I put my closed dot, and x is all numbers less than, so there is my arrow going to the left. Number 4. M is greater than -6. So I know I'm going to be starting at -6, and I think, am I going to do an open circle or a closed dot? Well, here I don't see the equal to sign, so I'm going to use an open circle. I go to -6, I do an open circle, and m is all numbers greater than -6. Okay, last example. -5 is greater than or equal to a. I've seen equal to sign, so I question, am I going to use an open circle here or a closed dot? Since -5 could equal a, I'm definitely going to use a closed dot. And now I have to consider, which way will my arrow go? Well, if I read this with regards to the a, I think a is all numbers less than or equal to -5. The alligator mouth is opening to this number -5, so that means a has to be numbers less than -5. So I'm going to draw my arrow to the left. Okay, so that is just simply graphing variable inequalities. Now we're going to do some math beforehand. Moving on to the next worksheet in the link for this section. Okay, now we're working on solving one-step inequalities by adding or subtracting. Pretty much doing what we were just working on, but now we have to make sure that we have solved this inequality before we go to graph. So it's a lot like solving an equation. Looking at number 1, if this was an equal sign here, I had x plus 8 equals 18, I gotta think, what would my first step be? Well, I know I want to isolate x, so I would subtract 8 from both sides. I'm going to do the same thing here. I'm going to treat this inequality sign just like an equal sign and subtract 8 from both sides. And I'm left with x is greater than or equal to 10. And that's it. Now I can graph my solution. So I go to the number 10. I do a closed dot because x could possibly equal 10. And I do an arrow that shows that x is greater than or equal to 10. Number 2. Okay, again, I'm going to approach this just like I would as if this was an equal sign. I need to solve for x. I'm going to isolate x. So how do I get x alone? Well, I'm going to add 1 to both sides.